Hello everyone, welcome to another session of Schneider Electric PLC training tutorials where you will learn Schneider Electric PLC programming. So this is a continuation of our Schneider Electric PLC training, and in this lesson we are going to learn comparison operations, what they are and how to use them to be your PLC applications. So what is actually a comparison operation? A comparison operation is an operation that is used to compare two or more values or variables of the same data type. So you may want to compare them and perform some action based on that comparison. So the first comparison operation that we shall look at is the equality operation, and this operation gives a logic 1 and its output when the comparison of the inputs are equal, and the not equality, which is not equal to, it gives a logic 1 when the comparison of the two inputs are not equal. Then we have the greater than or equal to. So when the two inputs, when input 1 is greater or equal to input 2, then this gives a 1 at the logic output. While when the two operands, that is when the operand 1 is less than or equal to operand 2, this gives a logic 1 at the output. And for greater than, when operand 1 is strictly greater than operand 2, it gives a logic 1 at the output. And for the less than, when operand 1 is strictly less than operand 2, it gives a logic 1 also at the output. Then we have the compare block. So the compare block now is a merger of one of two of these operations. So it merges some of these operations in a single block. So you may want to perform one of two of these operations in one single operation, then you use the compare block. We are going to look at it. Okay, and finally we are going to see some demonstration in our Unity Pro software. Okay, so the software we are using is Unity Pro. You can download it from the Schneider Electric website. Okay, so we are going to begin first with a simple operation that we have built. Okay, we are using an up counter. We have already discussed counters in our previous tutorials. You can move up the series. You're going to see how to use counters in a PLC development. So we have discussed the different types of counters. Here we will be discussing, or we'll be using the up counter to study the comparison operations. So this is an up counter, and when we have a logic 1 at the count up parameter, then the counter value, the internal counter value will increment by 1. Okay, and when we have a logic 1 at the R parameter, the internal counter value will reset to 0. And when the preset counter value becomes the same as the current or the internal counter value, so when these two values become equivalent, then the output is set to 1. But we are not going to be using those operations, all of these operations here. We are just going to be making use of the internal counter value, to perform comparison operations. So you can clearly see here we are using the equality operator. So this operator evaluates what? It evaluates the value of these two operands of input 1 and input 2. So it compares them when input 1 equals input 2, then the output is Boolean in nature. The output now will be set to 1, that is, this equality variable will be toggled to the 1 state. Okay, so you can see that here we are using the current counter value, that is the internal counter value of count of 1. The count of 1 is this block. So we are making use of the internal counter value of count block 1. So we are constantly downloading this value here into the parameter input 1 and comparing it with input 2, which has been given the value 6. Okay, so this block is always enabled because we have just directly enabled the enable parameter. We are not controlling it with any logic, so it will always be active. So whenever we make changes on the counter block, then it was going to also run this block and perform this comparison and give the corresponding output. Okay, so when input 1 and input 2 are equivalent, then the equal 1 becomes true. Okay, hope that makes sense. Next also is a not equality. So this is a notation for the not equality. So EQ for equality, NE for not equality. And you can see that here also we are comparing still the internal counter value to the second input. So we are comparing it with 6. So as long as this value and 6 are not equivalent, then we are always going to have a true or the not equal output. Then for the greater than or equal to, we use the GE for greater than or equal to. Okay, and in this case, when the current counter value is greater or equal to 6, okay, then the greater than or equal to parameter will be set to logic 1, otherwise it is set to false. Okay, next we shall see is the less than. So the less than is a similar and is a direct opposite of the greater than or equal to. So the less than or equal to is a direct opposite of the greater than or equal to. So when the current counter value is less than or equal to 6, then this logic goes high. This logic is set to the logic 1 state. And likewise the greater than. So this is a GT is a greater than. So it is strictly greater than. So when the current counter value is strictly greater than 6, this output will be set to 1, otherwise it is set to 0. And then we have the less than, also the strictly less than. When the current counter value is strictly less than 6, then its output will be set to the logic 1 state, otherwise it is set to the logic low state. So we use this a lot in process development when we want to track counts of maybe packets, maybe of pallets, and we want to either turn off or on the output based on the logic. Maybe we want to stop the operation when the value becomes greater than a certain amount, where the current count is greater than, or want to turn on the output when the value is still less than or equal. So it depends on the application that you're building. You can use these different blocks. Then we have the compare block. Okay, so for the compare block now, the compare block now is a block we can control. It is controlled, okay, not only with the enabling input but also with the validation input. So we can control it with this validation input. So this validation input has to be in its logic 1 state before this block can be executed, before this block can release the different outputs. Okay, so in this case we are comparing the current counter value still with the value 6, and when this validates boolean variable becomes true, then the comparison takes place. Okay, the comparison will take place when this validate parameter becomes true. So when it is now true, depending on the different values for our current counter and the value of 6, then we are going to have different outputs. Okay, so when the current counter value is greater than 6, then the sub parameter, this parameter, okay, becomes true. All right, so when the current counter value is greater than 6, this parameter becomes true. When the current counter value is equal to 6, then this EQU parameter becomes true, otherwise it is false. And next, when this current counter parameter becomes less than 6, when it is less than 6, then this parameter, the less than 2, this parameter becomes true. And when both of the parameters are different, okay, so when they have different values, okay, irrespective of the values, when they are different, then this parameter will always be true, otherwise it will be false. Okay, all right, so hope that was clear enough. So now let's test this simulate it and see the different results. So I'll go open my software right now. Okay, so I've already pre-built the operation. I've already pre-built it. Okay, so you can do the same. I just went to my variable tables, that is my variables and FB instances, and I created some variables. You can do the same. You can see that I've created different variables. I've given them some memory addresses. So I've given them internal memory addresses. Okay, if you are working with some physical inputs, you can replace them with physical input variables. We have already addressed how to assign variables, input variables, output variables, memory variables to your different variables, how to tag them. We have explained them in an earlier tutorial. You can visit them to understand that. So I have defined them, and then I've given them some addresses. Okay, and I have used them to build my application. Okay, so this is my application. I'm just going to go ahead now to, first of all, I will analyze it. I've already analyzed. I was just going to build it. Okay, so this is our status bar. You can check for errors. You see we have no errors, no warning. And now I'll connect it to my PLC. Then I'll download my logic to the PLC. So I'll download it. I want to run after download. Yes. So allow the logic to download. Okay. Alright, so we are going to start by evaluating the different blocks. So you can see equal to, so 0 is not equal to 6, so the default value here is 0. Alright, so it's 0, counter value now is 0 because there's no count. Okay, so with the equality we have 0 at the output because 0 is not equal to 6, so it's 0. And here 0 is not equal to 6, so that is true for this block, so that's why we have true. Next, 0 is not greater than or equal to 6, so we have a false. 0 is less than or equal to 6. Yes, 0 is less than or equal to 6, so we have a true. And here we have 0 is not greater than 6, so it is false. And here 0 is less than 6. Okay, so 0 is strictly less than 6, so it is true. We have our comparison block. So our comparison block now, everything is false, false, false. Okay, even though the values are different, even though 0 is less than 6, they are false, so because the validation parameter has not been set to high. So let me put it high. So I will set it to logic 1 state. Okay, now you see both parameters are different. So 0 is different from 6. We have this true. 0 is less than 6. We have this true. Okay, so I'm just going to allow it in the 1 state so that it always execute when we modify the internal counter parameter. Alright, so this push button will constantly count this up. Okay, so I will count that up by setting that logic to 1. So it has gone 1, then I'll set it back to 0. So I'll increment it until it is 6. 0, set it to 1, set it to 0, set it to 1, I'll set it to 0, I'll set it to 1, so it is now 5, so it is still less than 6, so I'll now set it to 0, then I'll bring it to 6. Okay, so our counter is now 6, so you clearly see that the equality parameter goes through there, not equal to, so 6 and 6 they are equivalent, so this should be false obviously, and we have greater than or equal to 6 is greater or equal to 6. All right, so that is why we have this as true. Then here less than or equal to, so 6 is less than or equal to 6, so we have this as true. And greater than, okay, yeah, so 6 is not greater than 6, so it's false. Less than 6 is not less than 6, so we have this as false also. and here our block has already executed, so we have 6 6, and here they're equivalent, so just the equality parameter goes high. Okay, now let's go to a scenario where our parameter now becomes greater than 6. So here I will set it to 0, then I will set it to high. Good. So now it is 7. Okay, so let's see. So it is still not, so here 7 is not equal to 6, so this goes false. Here 7 is not equal to 6, so this goes true because it's not equal to block. Here 7 is greater or equal to 6, true. 7 is not less than or equal to 6, so it is false. Here 7 is greater than 6, true. And here 7 is not less than 6, so it is false. Okay, and here we have 7 and 6, so you can see here the greater than parameter is not true because 7 is greater than 6 and they are different, so it is true. Okay, so this block can solve a lot of problems. If you are using these operators, then you can just manage them using this single compare block. Okay, all right, so hope that makes sense. Like I said earlier, you can use this to track maybe packets entering into an entering conveyor, or maybe packets going out of an exit conveyor, and you may want to start or stop the conveyor, maybe depending on the counter value. All right, okay, hope that makes sense. All right, so let's go back to our presentation. Okay, so let's see what we have learned in this course. So we have now understood that for the equality operator, the comparison is true if input 1 and 2 are equivalent. Okay, so you should note that these equality operations, okay, they can go up to 32. Okay, you can compare more than one variables. All right, let me just go back a little bit. Okay, sorry, I forgot to show you that. So I will just stop the simulation. Okay, I'll just disconnect it. So you can see that this block, if I highlight it, like for the equality, I have this dark dot here. This dark dot means that I can extend the operands. Okay, so you can put your mouse on it and pull it down. You can extend the operand, so you can compare multiple values here. All right, you can perform multiple comparison. For the not equality, you can just perform just operation on just 2 parameters. So that's why we don't have the dot here. For greater than, we can also extend it and compare. So I will just put it down like that. So we can also compare, okay, using the greater than, we can compare multiple parameters if they are greater or equal to. All right, and likewise this also, so it is determined by these dark dots here. Likewise this, okay, less than or equal. So you can take up to 32 operands, input operands. All right, okay, so that was just something important to mention. Okay, all right, good. So let's go back. Okay, so we talked about the equality. Okay, so the not equality comparison is true if the first operand is not equal to the second operand. Greater than or equal to is true if the first operand is greater or equal to the second operand. Less than or equals to, the comparison is true if the first operand is less than or equal to the second operand. Greater than, the comparison is true if the first operand is greater than, strictly greater than the second operand. And less than is when the comparison is true when the operand is less than, strictly less than or equals to the second operand. And for the compare block, when the val parameter is true, then the function compares the first operand and the second operand and sets or resets its output. That is the sub output, the EQ output, the inf output, and the diff output. Okay, based on the result of the comparison. Okay, so that brings us to the end of this presentation. And in the next presentation, we are going to be talking about the math operations. All right, so please, if you like this video, give it a thumbs up, share it, and subscribe. And if there is anything that you think didn't explain well in this video, please put it in the comment section below. And if there are some mistakes which I made, please also put it in the comment section below so that I can maybe review the video again. Okay, so thank you very much for watching, and please stay tuned to all our upcoming videos by not forgetting to subscribe. Okay, so thanks for watching and see you in the next video.